Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Jabir Syami bin Azhar. Registration number 03DM20 F1013. Today we are gonna demonstrate lab 2 for the power electronic. Okay, first we have to identify the full wave bridge rectifier. Full wave rectifier is defined as the type of rectifier that converts both halves of each cycle of an alternating wave AC signal into a pulsating DC signal. Full wave rectifier are used to convert the AC voltage to DC voltage, requiring multiple diodes to construct. We should know that bridge rectifier and full wave rectifier is the same thing. Function of a freewheeling diode in circuit. Freewheeling diode is used to protect the circuit from unusual damage caused due to abrupt reduction in the current flowing through the circuit. It is also known as flyback diode and forms correct connection across the inductor to remove flyback voltage generated across it. A freewheeling diode has a specific function that it allows energy or current in an inductor to continue circulating after a period when energy had been stored in the inductor. It is called freewheeling because an inductor can be likened to flywheel, which wants to continue turning after it has been driven up to speed. A freewheeling diode is like a valve that allows the flywheel energy to be coupled and to a load and do useful work. It reduces the harmonics and it also reduces sparking and arcing across the mechanical switch so that it reduces to the voltage spike seen in an inductive load. Next, this is my sketch of the circuit diagram of bridge rectifier array load circuits. This is drawn by hand. Okay, next we go to the working principle of bridge rectifier circuit with array load. The bridge rectifier used for diodes that are arranged cleverly to convert the AC supply voltage to a DC supply voltage. The output signal of such a circuit is always of the same polarity regardless of the polarities of the input AC signal. Figure 2 depicts the circuit of a bridge rectifier with diodes interlocked in the bridge configuration. The AC signal is applied at the input terminal A and B, and the input is observed across the load resistor R1. Okay, in the first positive half cycle of the AC signal, the diodes D2 and D3 become forward biased and start conducting, and at the same time the diodes D1 and D4 will reverse bias and will not conduct. The current will flow through the load resistor via the two forward bias diodes. The voltage seen at the output will be positive at terminal D and negative at terminal C. Okay, next. Now during the negative half cycle of the AC signal, the diodes D1 and D4 will be forward biased and the diodes D2 and D3 will become reverse biased. The positive voltage will appear on the anode of D4 and negative voltage will be applied to the cathode of D1. It is worth noting that at this point that the current will be flowing through the load resistor will have the same direction as it has with the positive half circle. Therefore, no matter the polarity of the input signal, the output polarity will always be the same. We can also say that the negative half cycle of the AC signal has been inverted and is appearing as the positive voltage at the output. Okay, this is my sketch of the input waveform, diode waveform, the output waveform without the freewheeling diodes, and the output waveform with the freewheeling diodes. This is drawn at the presentation PowerPoint, not by hand. Okay, the second, the third, fourth, and fifth. Okay, for the conclusion, in the end, we managed to investigate the input and the output voltage waveform for the full wave rectifier or bridge rectifier. We also learned how to draw input and the output waveform based on the graph displayed by the oscilloscope. Then we also calculate the Vmax, VDC and VRMS from the waveform. By doing this lab experiment, we managed to further our understanding about the half wave rectifier and full wave rectifier. Okay, that's all from me. Thank you.